All right, welcome, guys. I'm going to give you a little lecture on the main types of nuclear reactions, alpha, beta, gamma, and then I'm also going to show you just some pictorial representations of fission and fusion. Okay? All right. All right, so first, I'm going to be using the same worksheet that I uploaded into Schoology, but I'm using the backside just for notes here. So we have three main particles to start here. You have alpha, you have beta, and you have gamma. Okay. Now it's worth stating that when a particle is going to emit a radioactive, when a nucleus is going to emit a radioactive particle, it has to be unstable. So typically, usually, your most radioactive elements are going to be the larger elements. So anything greater than lead, so lead is Pb, I believe it's element 82 on the periodic table. Anything larger than that, usually that's where you're going to run into your more radioactive elements. So what they do is they emit particles to become more stable. So they might emit an alpha particle or a beta or a gamma to become a more stable atom. Okay? But when they emit an alpha particle, what an alpha particle looks like is a 4 over 2 helium. Okay, so it's a 4-2 helium nucleus. Essentially, when a compound or when a nucleus emits an alpha particle, it's emitting a helium atom. Okay, beta, a beta particle is a 0, -1 electron. Okay, and then gamma is pure energy. Okay, so gamma is 0, 0. So gamma has no mass. Okay, it's all energy. So when a gamma particle is emitted, it's usually also with maybe an alpha, maybe a beta. It's accompanied typically with other stuff as well. Okay, so those are the three main types. You also have two types of reactions that are called fission and fusion. Okay, and I'll show you pictorially what they are. And that's kind of the best way to go about it. So fission, and this is how our nuclear power plants undergo their energy process. How they create energy is through a fission reaction. Okay, a fission reaction is when you have a large atom, typically it's like uranium, so let's say 235, and uranium's 92, and what happens is you shoot a tiny little neutron at it. Okay, now that tiny neutron hits that uranium atom, and that uranium atom breaks into two smaller daughter nuclei, as well as three little neutrons. Okay, so the daughter nuclei might be something like, I don't know, barium and krypton. Okay, you can look at the periodic table and see that barium is much smaller. It's like element 56, and krypton is something like 36. Okay, and then you have, this is a neutron, and then you also emit three new neutrons. Now, these three new neutrons right here are going to then go on to hit other uranium atoms and propagate forward that fission reaction until you reach a lot of energy that's produced. So it can keep on going for a long time until you hit like a critical mass point, and you either get an explosion or some sort of huge amount of energy release. So nuclear bombs, the nuclear bombs that were used in World War II were fission bombs. Okay, now fusion is the other end of it. Fusion is what our sun uses. Okay, essentially it takes two hydrogens, so two relatively small nuclei, and let's just say that these aren't drawn to scale. Okay, so this is a hydrogen, this is a hydrogen, and under extreme heat, it throws them together, and they fuse to form a larger atom. So like, let's say it's a helium atom. In the process of fusing together, it releases a whole heck of a lot of energy. Okay, and we see this every day because the sun is undergoing a fusion reaction, billions upon billions upon billions of times per second, and that's obviously how we get our heat, and our life source is through the sun. So it burns through a lot of hydrogen. It fuses a lot of hydrogen into helium. Okay, so fusion reaction, fission reaction, and then you have alpha, beta, gamma. Okay, now let me show you a couple of examples of how this would look. Okay, so first, let me just adjust the camera so we can get a little bit closer here. All right, here we go. What you have to do first within this worksheet is you have to fill in the blank of what should be there in terms of your type of reaction. So in looking at this is really all just about balancing numbers. Okay, so if you look at the first problem, you have 222 over 86, and the element is Rn, which is radon. Okay, and then on the other side of the arrow, you have a blank, and you have a 4 over 2 helium. Okay, now what you have to ask yourself is you have to fill in this blank, and you need to say, okay, well, I need the numbers on the top and the numbers on the bottom to equal. And the arrow, the yield sign, represents kind of like a dividing line. So you have to say, okay, well, I have 222 on one side, and I have 4 on the other. What plus 4 equals 222? That's the thought process. And of course, that number is 218. Okay, then you ask yourself, well, I have 86 on one side, and I have 2 on the other. What plus 2 equals 86? And it's 84. Okay, and then to figure out what element that is, you look on your periodic table, and you say, okay, well, what element is element 84? And it's polonium. Okay, so this is balancing a nuclear reaction. What we just did was balancing a nuclear reaction. And the type of reaction that is, usually you look for that particle. Okay, the particle that's very noticeable. So this would be an alpha decay or an alpha particle. Okay, so that's kind of the thought process. Now, some of them can be a little bit trickier. When you have a beta particle in there, it's important to note that you have the -1. So keep that in mind. So we can try this one together. We can do 2 together. So right off the bat, I kind of gave it away. This is a beta particle. So a 0 over -1e is beta decay. Okay, and then you ask yourself, all right, well, I have 214 on one side, and I have 0 on the other. What plus 0 gives me 214? It's pretty easy math, 214. And then you say, okay, well, I have -1 on one side, and I have 82 on the other. What plus -1 gives me 82? Okay, and that's 83. Element 83 is bismuth, Bi. Okay, so it really isn't that much harder than that. So I don't want to spoil too many of these other ones. I want you guys to try these ones down below and see if you can get them. The other end of it, when you look down here, like if you look at 8, 8's asking you to write a balanced nuclear equation for beta, alpha, and gamma decay of radium-226. Okay, so what you're going to do in each case is you're going to start with radium-226. So radium is Ra. The mass is 226. And then Ra is element 88. Okay, now if it's alpha decay, you would then take an alpha particle and it would go in the products. So I'd say 4 over 2 He. Okay, now is this a balanced nuclear equation? No, because your numbers aren't equal on both sides of the arrow. Okay, so I have 226 over here. I have 4 on the other side. So you'd say, okay, well, I need to figure out what goes here. And you would do the math. So I'll give you a hint. This top number is going to be 222. This bottom number is going to be 86. And then I'd say, okay, well, what is element 86? Looking at the table, element 86 is radon, Rn. And that's it. I got it. I'm done. I go on to the next one. Okay. What I want you guys to do is to try this worksheet. Okay, there's 2 sides to it. It's front and back. If you get stuck, I want you to refer to the 2 videos that I'm going to post in Schoology for Alpha and Beta. Okay, it's going to kind of walk you through and show you how to set those up and how to answer those types of problems that you'll run in this worksheet. Okay, I'm going to give or leave a key with the sub so he can help you guys. If you have questions, you can come on up and ask, like, well, what should the answer be for this one? And he can kind of show you. Okay. All right. Hope this helps. Hope to be back Wednesday. I'll see you guys.